So as usual, let's just get to it. The main goal today is to move from our data, collected in that very particular way that we did, and processed in that very particular way that we did, and turn it into something that PyTorch can use to train and then execute deep learning models. We are using PyTorch just because we happen to like it. There are many other libraries which are equally good, but in this course we will focus on PyTorch. In this first video, a couple of words about, let's say, environment. Today I am doing this session online because today I have a reliable internet connection, so I'm taking advantage of that, and I am running this completely in Google Colab. If you do this, well, you should be aware that any file that you use in many previous units, we didn't need to use that many files, but today we will be using quite a lot of them. So when we download, for example, using this wget command here from Dropbox, from a Dropbox link, when we do this, the files that we download get downloaded to the folder where the Jupyter notebook is being run. Where is this Colab notebook being run? Well, it is run in a computer that's in somewhere, some Google farm that's owned by Google. In my computer, I'm just seeing a screen that connects me to that remote computer. Okay, so when I download files, and here in this first cell, basically, we are repeating what we did in Unit 3. So if you want to understand that precisely, go back and check that one out. But basically, we are downloading some files which contain a mosaic, an orthomosaic captured by a drone over a forest in Zao Mountain here in Yamagata Prefecture in Japan. And then we had some people from the Faculty of Agriculture do handmade annotations marking where all the species, where each species of the subalpine bushes that we are interested in this particular project are located. And then we use that information to cut patches around each bush, if subalpine bush. So we ended up with a folder full of images that each contained a number and the name of the class that was imaged in that patch. You remember all that good stuff. Annotations that were points to know exactly where each bush was located, connected components to find the coordinates of those points, and then for each species we had a binary mask that told us where the species was. So for each point we went and checked what species mask it belonged to. Okay, so have run all of this. I have first downloaded the data. I'm not running it now because it takes a little while, but I already did. And I have run everything, and I have run the code from the previous unit. So what I have now in my hard drive is a folder with all those images with the name that indicates what species is in each of them in one folder. Okay, but where is that folder? Well, if you happen to have downloaded this Jupyter notebook, remember, file, download, and you can do it here. They are in your hard drive, in your own computer. But I haven't. I'm running this in Colab. So I have them here. See? This files folder. So I have the ZaoSat5, which contains the data that I downloaded originally. And I have the patches folder that I have just created. Okay? And it doesn't want to open it now. Okay, now. So I have all of those images. I wonder if I can click one. Can I? No, it's not showing it to me. Double click? Yes, double click here. I have one image here, another image here. I can see them here too. Okay. So these are not in my local machine's hard drive. They are in Google Colab's machine. Okay. So important thing, when I close this browser tab, they are going to get erased. Okay, Google will clean up everything that I have made. So if I'm running this in Colab again, I will need to run this first cell again. If you're running it in your local computer, you will not have to do this. Here are a bunch of outputs that are created by the downloader and different things. It's a good thing to have a look at it and see if there was some error. There wasn't any here. And having spoken a little bit about the environment, let's just say a couple of preliminary things just before we get into the actual action. First, just present PyTorch a little bit more. PyTorch is a machine learning and deep learning library that contains many algorithms. It's very current. Anything that's published, it gets added super quick into PyTorch. And we have lots of functions that can help us build our own networks, use those that have already been built, do all the things that we might want to do. In this session, we are going to be focusing on creating our own PyTorch dataset, on working with our own data. Sometimes when one is learning to use deep learning and what deep learning is, maybe what some people prefer to do first is to use existing datasets. There are many famous ones like ImageNet, MNIST, or even, for example, the Kusujiji, MNIST, Kanji, and Hiragana dataset. And people use those so they don't have to worry about how to get data and what data to get and whether the data is good or not. So they just use some pre-prepared data set and then they focus on the deep learning network part. Okay, so that's also fine. If you want to do that, then the data set and data loader part will not be as important because someone will have taken care of that before you, and you can do this in this tutorial. PyTorch is a super popular library, and because of that it has many tutorials. The PyTorch tutorials themselves are very good and very useful. So if you are most interested in that, by all means go have a look, but that's not what we will be doing today here. Final word of preparation. I mentioned that we have all of our patches in one single folder and that they have a name that includes the class. For example, this one is Inotsuge patch 0 JPEG. Okay, so that means that the class depicted here is Inotsuge, and it has the word patch, so we all know that's a patch, and the number 0 and the extension. Okay, but all the patches from all the classes are here. Okay, so here, for example, I have Kaide. Okay, or if I go a little bit further down, I will have Kiaraboku, for example, or I have 6 classes, so I will eventually find Nanakamado and Sakura too. Different classes that I have. Kiaraboku is very frequent, as you can see. Okay, so I have probably already passed the other classes. Kaide, Inotsuge. Okay, I'm going to have to check, but I have all the patches with all my classes here. And the thing is that I have all of them into just one folder, many of them. Okay, so all of the files are mixed together in one single folder. Okay, I think it's just not, oh yeah, I have 3 points here. The other classes are further down, but Google Colab doesn't want to show them to me. Okay, so no problem, they are there, believe me. All the patches, all the images are in one folder. Another way to do this, and we could have just as easily have done it that way, would have been to make one folder for each class. If you do it that way, then there is a class that's already prepared that's called the image folder class. Okay, and you can go and use that one too. Okay, so if you want to adapt the code in Unit 3, this code, so that instead of storing all patches in the same folder, patches from different categories are stored in different folders, then you can make the code shorter, but using the image folder class. But we want to see a little bit more detail about how to make the data accessible for PyTorch, so we will be using something different. We will be using custom datasets and in PyTorch, so we will be using the data loader and the dataset classes in PyTorch.